Okay, so let's talk a little bit more about voltaic cells. So those are the spontaneous redox reactions. And from here, I want you to be able to identify the reduction and oxidation reactions. And we're going to add some new terminology as far as like cathode and anode, salt bridge, those sorts of things. So all electrochemical setups, all electrochemical cells have what we call an anode and a cathode. The anode is defined as where you have oxidation occurring. All right, so if you remember LEO, lose electrons, oxidation. All right, oxidation means that you're going to produce something that has lost its electrons. So your products are going to have some electrons on their own, or a positive ion. The cathode is where reduction takes place. All right, if you remember, that was gain electrons reduction. So you can see the copper is gaining the electrons. The copper ion is going to pick up those electrons. All right, the way I remember that anode and oxidation go together and cathode and reduction go together, anode and oxidation both start with vowels. Cathode and reduction both start with consonants. So here's a sample. What is this reaction? All right, we are taking copper, adding electrons to make solid copper. So copper ion is gaining some electrons to become copper. Gain electrons. So this reaction is reduction. All right, reduction starts with R, which is a consonant. So that means this is my cathode cell. All right, on the other side, we've got zinc being split into a zinc ion and 2 electrons. All right, so we're losing electrons, LEO. That means this is oxidation. And this is our anode. All right. Couple other components to kind of make note of is there's this salt bridge in the center here. What this salt bridge does is as these electrons travel through the wire, we are losing some negative charge in this beaker. So these sulfate ions transfer in to offset that loss of negative charge. All right, and then the salt bridge on the other side, here those electrons are gonna come in, we're gaining some extra negative charge. So sodium 2 plus, 2 of them, come over to offset that increase in negative. All right, we talked about this on the last one, but which directions do the electrons always move? They always go from your anode to your cathode. All right, and the salt bridge balances your charge. Those negative sulfate ions come in for the electrons that are being given away so that we still stay neutral over here. And then the sodium ions add to the left side as those electrons come in so that we stay neutral over there. All right, so this is something you really want to remember about anodes and cathodes. All right, and this is the same for all electrochemical cells. Anode is always the site of oxidation, cathode is always the site of reduction. You know, the charge on the anode is going to be negative because that's where the electrons are being created. Charge on the cathode is positive. The only thing that on this list will change when we talk about electrochemicals, electrolytic cells, is this middle one, the metal activity. This is written so that you'll get spontaneous reactions. All right, but the direction of your electron flow is still going to be out of the anode into the cathode. So let's apply this to a question. In the diagram below, if electrons flow from the right half cell to the left one through the wire, which side oxidizes? All right, so our electrons are going to go this way, from the right one to the left one. All right. Which one is oxidizing? All right, we know we always travel from your anode to your cathode. An anode equals oxidation. Those are both starting with vowels. So the right side is your anode.